Averages lie, lalo na kung completely ignored ang variability. Mean, median, and mode are absolutely fantastic for finding the center of your data, but they have a massive structural limitation. Binababawala nila yung mismong spread ng process mo. Bilang mga Lean Six Sigma practitioners, we don't just look at the middle, we literally master the variation. Sa explainer na ito, i-dissect natin kung bakit ang pag-unawa sa spread ng data mo is absolutely crucial and, honestly, ang pinakamahalagang hakbang para ma-stabilize ang kahit anong operation.
Okay, let's dive into our roadmap for this session. Magsisimula tayo sa the lie of averages, followed by range and its limits, calculating and interpreting standard deviation, z-scores for individuals, and we'll wrap it up with the business impact of variation. Section 1, the lie of averages, ignoring the process spread.
So bakit nga ba mapanganib umasa lang sa averages? We're peeling back the first layer of the onion here. Kapag nakafocus ka lang sa middle number, you're practically blind sa tunay na nangyayari sa magkabilang dulo ng proseso mo. Let's anchor this with a classic Filipino BPO scenario, okay? Imagine two customer service teams on your floor. Parehong may average handling time o AHT na exactly 10 minutes. Sa team Pagsanhan, very consistent, every single agent finishes their calls between 9 and 11 minutes. Pero tingnan mo ang team Sampalok. One agent drops a call in 2 minutes while another drags on for 18 minutes. Pareho silang 10 minutes sa client dashboard, right? Pero operationally, Team Sampalok is in pure, unpredictable chaos.
Para makabuild tayo ng stable processes, we absolutely must look at the edges of the dataset. Kaya nga nating i-measure ang variability. In simple terms, how close or far apart are these data points from each other? Upang magawa ito, we rely on two primary metrics, ang range at ang standard deviation. Section 2, range and its limits. Measuring the edges.
So let's talk about the range. Ito ang pinakasimpleng measure ng variability. Kinocompute ito by simply subtracting the minimum value from the maximum value. Napakadali, right? Pero kailangan nating silipin kung bakit hindi ito sapat para sa malalalim na analysis. Let's set up a BPO nesting wave baseline exam scenario. Sabihin natin na ang iyong wave ng 15 customer service agents ay may mean na 60 at median na 58.
Tapos biglang nakita mo sa team dashboard na ang range ay 70. That is a massive number. To put that into perspective, looking at a range of 70, a supervisor might easily jump to the wrong conclusion. Baka isipin niya na ang scores are evenly spread out from a low of 25 all the way to a high of 95.
Pero kapag plinot natin ang raw data, the real story emerges. Ang minimum score pala ay 10 at ang maximum ay 80. So, bakit pumutok sa 70 ang range natin? Dahil sa isang rogue agent na hindi nag-aral at nakascore ng 10. Because range only uses two data points, literally just the absolute highest and lowest, it is highly unstable. Isipin mo, one single outlier makes a perfectly disciplined team look completely out of control. We clearly need a better metric.
Section 3, calculating standard deviation, measuring collective chaos.
Dito na papasok ang ultimate solution sa unstable range problem natin. Kailangan natin ng tool na kayang i-evaluate every single data point simultaneously. Enter standard deviation, or sigma. It measures variability by considering the position of every single data point relative to the process mean. Sa Lean Six Sigma logic natin, it mathematically represents the average square distance from the mean. So hindi tulad ng range na nakatingin lang sa dalawang extreme ends, standard deviation captures the collective chaos of your entire operation, kasama lahat.
Let's set up a practical walkthrough. Gamit itong 4 agents go with. Dito nakalatag ang raw data natin for our variance calculation. Agent 1 takes 2 minutes, Agent 2 takes 8, Agent 3 is at 10, and Agent 4 takes 12 minutes.
Paano ba ito i-compute manually step by step? First, find the mean, which is 8, and our sample size, which is 4. Second, subtract the mean from each point and square the result. Third, sum the numbers up, giving us 56. Fourth, divide by n-1 to get the variance, which gives us 18.7. Finally, take the square root, and boom, we get a standard deviation of 4.32 minutes. Now, a quick modernization note. While it's absolutely essential to understand these manual steps for your Lean Six Sigma foundations, real talk, Microsoft Excel automates this instantly using the SDEDV formula. Let the tech do the heavy lifting.
Section 4. Interpreting Standard Deviation. Understanding Scale.
Ngayon, kung may nakuha kang standard deviation na 20, the big question is that good or bad? Well, it depends entirely on your context. Scale is everything. Kung iisipin mo ang climate data, a standard deviation of 20 degrees Celsius in a single summer month, that's an incredibly chaotic climate. Literal na magkakasakit lahat. Pero kung annual tech support salaries yan in a global company, a $200 standard deviation is negligible, meaning highly standardized ang pay grades mo. Back on the BPO floor, a small standard deviation indicates a tight, highly stable process. Uniform ang execution and highly predictable ang metrics mo. Pero kapag large ang standard deviation, massive red flag yan. That means deep operational instability. May massive inconsistency, which tells us that the floor lacks standard work instructions.
Section 5, Z-Scores for Individuals, Defining the Ecosystem.
Okay, so we've looked at the collective team performance. Pero paano natin i-analyze ang individual fibers ng data natin? Dito na papasok ang Z-Score. A Z-score measures exactly how many standard deviations a single individual data point sits away from the process mean. To picture this, let's look at a tech support scenario. Sabihin natin na may baseline mean resolution time tayo na 139 minutes at standard deviation na 41 minutes.
Nakakita ka ngayon ng isang complex ticket na umabot ng 231 minutes. Kapag kinompute natin, ang Z-score niya ay positive 2.24. What does that actually mean? It signifies an exceptionally long delay dahil lagpas 2 standard deviation siya away from the mean. On the flip side, may faster ticket na 112 minutes, dropping our Z-score to negative 0.66. Ibig sabihin, this ticket is comfortably close to the center of your regular operations. With this, you can instantly define the severity of any single transaction within your ecosystem.
Section 6, Business Impact of Variation. Let's look at the operational reality.
So, why does all of this matter sa isang yellow belt o green belt na nagpapatakbo ng floor? Ibabalik ko kayo sa ating Microsoft Modernization Anchor. Let Power BI or Excel run all these complex formulas for you. Your real job is to interpret what the variance is screaming at you. Kapag nakita mong wildly skewed ang Z-scores, that is your cue to open a data-driven discussion. The goal is to spot hidden chaos and outliers, target those structural inconsistencies and fix them. Maging operational ay ito para magtanong, issue ba ito sa tool loading speeds o kailangan ba natin ng standard desktop layouts to eliminate waste or muda?
And this brilliantly illustrates kung bakit vital ang data literacy. I want to leave you with this provocative thought. Are our data collection methods actually capturing the true workflow? Or is an uncalibrated logging system breaking our metrics? Huwag tayong basta-basta umasa sa averages. Find the variation, ask the hard operational questions, and move your team closer to predictable, world-class service delivery.